Hi, I wanted to take a look at two interesting DX7 patches I found on the internet. I'll put a link in the description to where I found them. And these are both robot voices. But they work differently on the inside, so I thought it'd be interesting to look through that. So this one uses algorithm 17. And that means we have one carrier and three things coming together into that carrier. So let's see how the operators are used. And we can do that by turning them off one by one. So one is the carrier. See, the sound disappears when I turn it off. Operator 2 does nothing. Operator 3 does something. Operator 4 does nothing. Operator 5 does something. And I don't know if you can hear it, but operator 6 is doing something very subtle. It creates a kind of beating effect after the sound has settled, and that you don't have that if you turn operator 6 off. But I think for the purpose of analyzing the sound, we can ignore that part. So then we only have three operators left. Let me get the picture again. So we have operator 1 and 3 and 5 are going into 1, and we're ignoring the other 3. Now where's the movement coming from of this? It's like the robot's mouth is moving. And I know the answer already because it's coming from one of the amplitude envelopes. I think it's number 3. Yeah. So it starts here at 71 and it goes to 99 and it goes there kind of slow. So that's the rising sound you hear. We can also add some more movement if we take the level down here again. We slow that down a bit. Okay, so this envelope is the robot mouth. This envelope isn't really doing something, and much this carrier envelope, it's just the same level all the way through. And the fifth operator is, it also has the same level all the way through, so it's not really doing much. So what are the frequencies? Keep pushing the wrong button because the camera is in the way. So here we have the carrier that's at 0.5. So it's down an octave from the normal pitch. Actually, if we look here, it's down 2 octaves because the normal pitch would have been C3 and the center is now C2. Okay, so that one is at 0.5. Then we have the one that is the mouth movement, that's also at 0.5. And then there's the third one and it's about 14. So what happens if we change that? It sort of changes the color of the sound, but it doesn't make the robot effect happen. Or like you can move it around quite a bit and still get a robot. What about the other one? This doesn't sound like a voice anymore. So this one really has to be all the way down there with the carrier to get the vocal effect. And I think we've seen everything now because there's no LFO and this amplitude sensitivity isn't really doing anything. There's no pitch envelope. All these levels are at 50. So let's see if we can recreate this. And to make it interesting, let's use a different algorithm, like this one, number 7, because it has 2 operators going into 1, because I think that's the key for this sound. So we're going to have 4 and 5 going into 3. First we initialize this, adjust the sine wave, and then 3 is our carrier. We're not using 1. And then the 4th operator is going to be this slow moving sound. I forgot to show you the levels, but this one is at 97 in the original. And I still have operators turned off. We got to set the pitch correctly. So over here. And then it goes even lower. And 4 is also at this level. Right, so that's the mouth. And now the mouth needs to move. And it was starting from 71. And going with the rate 38. So that's the right movement, but it doesn't sound like a robot yet. And for that we need the 5th one, the 5th operator. And let's see, its level has to be about 72. That's not a robot. So we need to go up in pitch with about 14. I think it's too loud now. Okay, this is fun. I'm doing something wrong. Was it 72? This is over-modulating. Why is that? Because we're on the wrong algorithm. There we go. Algorithm 7. Sounds pretty close to me. Now let's check out the second robot. What's going on here? So we have algorithm 18. That's again 3 into 1. And let's see what the what the individual oscillators do. So 1 is the carrier. 2 is part of the robot. 3 does nothing. It's really only 1 and 2. You can already see that the frequencies are 0.5 for the carrier and fixed frequency. And if we change that, change the robot sound, but it doesn't go away. And that's because the robot is coming from the LFO. Yeah, that's the robot. And we have a very high modulation depth. This is 99. And on the sensitivity page, we're on 7. that to get the full robot. And then the articulation is in the pitch envelope. So here we see 989. The neutral level, neutral pitch is 50. So this is going 8 octaves up. If we change the rate, we'll change the articulation, the movement of the robot mouth. And it kind of goes past the vowel sound, so maybe it should be a little lower. There's also level 3. Let's take that down a bit and do a slow glide down there. It's quite sensitive to this level. I think we can recreate this. Let's see. First we need to initialize, and we only need 2 operators. So we set the first one to 0.5 and the second one to a fixed level. In the 900 range. This needs to be about here. Then we need a maximum pitch sensitivity, maximum depth, and a square wave. To go faster. Doesn't sound quite right. Maybe we're still missing the pitch envelope. Yeah, I think that's it. That wasn't too hard, and it's remarkably simple because it only has the 2 operators, but the LFO is kind of acting like a third oscillator because it has such a big impact on the sound. And we use the pitch envelope to do the articulation. So it's quite different from the first one. With the first one, you had 2 sounds that were combining, and one of them, the amplitude envelope of the first one, was sort of the mouth movement. And you had 2 operators going to a third one, so 3 operators total. No LFO, no pitch envelope. Here we have 2 operators, but we have the LFO as a kind of third operator, and the pitch envelope is doing the mouth movement. Sounds very similar in the end. Well, that was it. Thanks for watching.